Hello, this lesson is on composite functions. All right, so what are composite functions? A composition of functions is really just an operation where two functions are used to generate a new function. So it looks like this. This is kind of the way that I prefer it to be read, but there are other ways to write it as well, which you'll see. But this is read f of g of x, and we kind of always start with the inside and work our way out. So that's what we're going to think about today, and we'll apply that. And then just a couple other things about this. Really what you're doing is you're taking the output from one function and then using it as the input for the second function. So you'll see what that means here in a second. Before we talk about that, there are a couple of different ways that we can write a composition of functions. So we can write it like we just kind of wrote on the previous slide, which is f of g of x, or you can also do this with this open circle in the middle. So this also means the same as this and vice versa. So if you see either one of those, you should interpret that. I will end up with this one because it's a little easier to function with at the end. But if you start with this, you should think, oh, that's the same as this. So that applies for any function, and you can also start with f of x on the inside, g of x. It doesn't matter what the order is. Well, it does matter what the order is, but you can write them in any way. Your answer will be a little different though. Okay. You can even do like g of x. So you could do the same function twice. Okay. Now, how does this work? The best way to try these things is to just get used to using them a little bit. And so we're going to do that. It says let f of x equal 2x minus 4 and g of x equal 5 minus x. Evaluate the composite functions below. So the first one says here f of g of 3. So as I said before, what you want to do is start on the inside and work your way out. So you're simply going to just say f of g of 3. So g of 3 means here's g of x. We're going to put a 3 here and a 3 here. We're simply just going to rewrite this. So this would be g of 3 would be equal to 5 minus 3. So that's 2. Okay, so my output, when I put a 3 in for x in the g function, I get an output of 2. So now this ends up being 2. So I'm going to write f of 2. So now what does that mean? So now that means I'm going to take the f function, and wherever I see an x, right, I'm going to put a 2. So this is going to be equals 2 times 2 minus 4. That's 4 minus 4, which would be 0. So my answer to f of g of 3 is 0. That's kind of weird, but you're really just doing a couple of functions at the same time. So I hope that kind of makes sense, but we'll just practice this a little bit more. I'll do a different color maybe for this one. All right, so this is G, and then it has the open circle f of 3. So remember, this really just means G of f of 3. And I like to write it like that because it just makes a little bit more sense. Okay. So I want to start on the inside. I want to do f of 3. So that means I'm going to put a 3 here. Okay. So really, that's 2 times 3 minus 4. Okay. So that 2 times 3 is 6 minus 4 is 2. So really this is g of 2. Okay. So now I'm going to go to the g function, and wherever I see an x, I'm going to put a 2. So this would be equal to 5 minus 2, which is 3. So the answer to this right here is 3. I guess over here it'd be 0, right? So hopefully that's starting to make a little bit of sense. And as I said, you can even do the same function, and that's what this last one is here. It says g of 3. So that would, I like to rewrite it again. So start on the inside. G of 3 would be 5 minus 3, which is 2. And then plug in 2 again. So 5 minus 2, which is 3. So hopefully that's starting to make a little bit of sense to you. That's how composite functions work. All right, so we're going to try slightly harder ones. And I have 3 functions here, and we're just going to only use the ones that are in each problem. So f of x is equal to x squared plus 6, g of x is equal to 2x to the 3rd, and then h of x is equal to 4x minus 7. So this first one says find h of f of 3. So we're going to start by doing f of 3, again on the inside and work your way out. So h of f of 3. So f of 3 is equal to 3 squared plus 6. So that's 9 plus 6, which is 15. Okay, so now I know that f of 3 is 15, so I'm going to write h of 15. And now I find the h function, and that's 4x minus 7. Okay, so I'm going to go 4 times 15 minus 7. And that's 60 minus 7, or 53. So h of f of 3 is 53. Okay, I hope this is starting to make a little bit of sense. Okay, let's do this one. It says g, so I'm going to go g of f of negative 1. Okay, f, I'm going to use this first function, and I'm going to do negative 1. It's a negative, so I'm going to put it in parentheses, squared, plus 6. So negative 1 squared is 1, plus 6. It's going to give me 7. So this is g, f of negative 1 would be equal to 7. So that's my output. Now I'm going to go into this function, the g function, and go 2 times 7 to the 3rd. Okay, so 7 to the 3rd is, you probably want to do that on your calculator, 7 times 7 times 7. You want to do that first. So that's 343, and then you're going to multiply that by 2, so that would be 686. So g of f of negative 1 is equal to 686. All right. Okay, and then this one has a bunch of things going on. And again, we're going to start on the inside and work our way out. It's no big deal. So I'm going to start with h of 0. Okay, so if I put a 0 here, I would have 4 times 0 minus 7, which is going to give me negative 7. Okay, so here's what I got so far. I got f of g of negative 7. Okay, and now I'm going to do g of negative 7. And I'm going to... So I got 2 Negative 7 to the third power. So it's almost the same as what we did here, but there's a negative. Now, negative 7 to the third power is negative 343. And then I need to take that times 2, which will give me negative 686. Okay, but now I need to do f of negative 686. So I'm going to go over to this function, and I'm going to say negative 686 squared plus 6. Okay, so that's a big number. It's 470,596, and then plus 6 is going to give you 470,602. And we'll write that over here. Okay, so there's my answer for that. Hopefully that's making sense to you. All right. Now we're going to just try a couple of ones that are just no numbers. We're just going to input the function into the other function and see how that works. So this one says f of g of x, and I'm going to write it the other way. Okay, so now I want to take this 5 minus x, so I'm just going to replace g of x now with 5 minus x. So what does this mean? It means wherever you see an x in the f function, you are going to put 5 minus x and then simplify. So this would be equal to 2 parenthesis in here, 5 minus x, and then minus 4. Okay, so all I have to do now is just simplify that function. So I'm gonna, or that expression. So I'm gonna distribute. Okay, and then what I have is 10 and negative 4. I can put that together. That's 6. And then I have minus 2x. So f of g of x is equal to 6 minus 2x. You could also write it as negative 2x plus 6. However you want to do that, either way is fine. But that is how you take one function into another function. It's called composition of functions. Okay, so you won't get the same answer if you flip it around. So we're going to do the other way and see what happens. So the order does matter that we do these, right? So this is g of f of x. So in this case, f of x is 2x minus 4. So I'm just going to put that here. Instead of f of x, I'm going to write 2x minus 4, since that's what it says right here, right? That's the output. All right, so now in the other function, g function, wherever I see an x, I'm going to put 2x minus 4 instead. So this would be equal to 5 minus, and then don't forget the parenthesis because there's multiple terms here, 2x minus 4. So now I need to just simplify this. Remember, this is really like a negative 1 in the front that I'd have to distribute. So this would be 5 minus 2x plus 4. Simplify that. 5 plus 4 is 9 minus 2x. And there we go. We've just done composition of functions both ways. Hopefully that's starting to make some sense to you. All right. I'll do a slightly harder one, and then I want to do a quick word problem, and then that would be it. Okay. So again, let's try this slightly harder. F of x is x squared plus 6. This is kind of the same thing that we saw previously. G of x is 2x to the third, and then h of x is 4x minus 7. So this says find f of g of x. Okay, I'm getting pretty good at this now, so let's see here. Let's go. G of x is 2x to the third. So I'm going to put in to this function 2x to the third squared plus 6. So I'm just simply replacing, in place of x, I'm going to put 2x to the third. So that's what I just did. Now simplify that. When you simplify, remember the squared goes on this and it goes on this. When you have power of a power, you multiply. So this would be 2 squared, and then 3 times 2 is 6, plus 4, which is 4x to the 6th plus 4. I'm sorry, plus 6. I don't know where I got that. Okay, and there's your answer. All right. Now, what about this one? All right, so this is f of h of x. H of x is 4x minus 7. And we're going to put that into the f function. So this will require a little bit more work. We're going to go, this is 4x minus 7 squared, and then plus 6. All right. Now, let's see if I need to do 4x minus 7 squared. If you remember, I think maybe actually I'll do it up here. So 4x minus 7 times 4x minus 7 is what that means. And you can't forget that. Don't just square the first term and the second term. You'll get it wrong. So 4x, I'm going to distribute. I got to go this times this times this. So that's 16x squared. And then 4x times negative 7 is negative 28x. And then negative 7 times both of these. So negative 7 times 4x is negative 28x. Negative 7 times negative 7 is positive 49. So this would be 16x squared minus 56x plus 49. Okay, so you got to do that. And then I'm going to come back down here. All right, so I have 16x squared minus 56x plus 49. And then don't forget this, the plus 6. Okay, so my answer would be 16x squared minus 56x plus 55. Hopefully, that's making some sense. All right. Clothes you wear post discounts on social media. The store allows customers to use multiple discounts. They simply need to tell the cashier in order that they'd like the discounts to be applied. So you write your functions to model the discounts. Let X represent the price of the purchase. Okay, for $5 off your next purchase, if we say that X is the price, this would simply be X minus 5. Okay, for 10% off, we'd have to go, all right, the price minus 10%. So that would be, let's see, the original price. Sorry, there we go. And then minus 0.10 or 0.1 times the price, which would give us, that'd be 1x minus 0.1 would be 0.9x. So 10% off means we'd be left with paying 90% of it. So that makes sense, 0.9x. All right. Identify the rule for choosing 10% off followed by 5% off. So remember, we always work inside out. So if we start with 10% off, we want that first. So that g of x would have to be on the inside, and then we would put the f of x on the outside. So it would look like that. So write it in function notation, it would look like that. Okay, and then identify the rule for choosing $5 off followed by 10% off. Write it in function notation. Well, this would be the other way. We want the f of x on the inside. Okay, there we go. All right, and then suppose you are buying a shirt for $30. Which of the discounts would result in the lowest price? So if we do f of g of x, we would have f of g of x is 0.9x. And then if I plug that in, I guess I could write this here. Okay, so now if I take that and put this 0.9x in there, I would end up with 0.9x minus 5. And then the other one, okay, like this. And so f of x is x minus 5. And then we plug that in here. So that would be, I guess, 0.9 times x minus 5. So distribute that, that would be 0.9x minus 4.5. There we go. Okay, so which one's gonna be better? Well, you're gonna have more money off because this would be minus $5, this would be minus 4.5, so 90%. So which one is better? This is better. So how much, which would result in the lowest price? If you plugged in 30 for this, you would get, you put in 30 here, you'd end up with, that would be $22. If you plugged in 30 for this one, you'd end up with $22.50. So clearly this is the better one. Hope that makes sense. This is composition of functions. You can go ahead and get started on the assignment. Good luck. See ya.